Thank you everyone for joining us this afternoon for joining SME Membership's program. Today, SME's proud corporate member Humtown Products will present when to utilize additive manufacturing to complement your metal casting needs. SME membership continues to expand opportunities for member engagement and thought leadership through its SME corporate member sponsored webinar series. This initiative brings together manufacturers and solution providers to exchange insights and explore new strategies for industry challenges. Open to both SME members and the broader manufacturing community, this webinar reflects SME membership's commitment to supporting professionals through relevant and high-impact content. Before we get started, a few housekeeping items. All attendees are muted today to minimize background noise. We strongly encourage you to use the chat feature throughout today's program to submit your thoughts and questions for the content provided. We will try to answer some of the questions during the presentation, as well as in a Q&A portion at the end. This event is being recorded, and a replay link will be emailed to all registrants at the conclusion. For any post-event questions, please email SME membership at membership@sme.org. With that, I'm going to turn it over to Brandon.
All right, thank you so much. Really appreciate the opportunity to be here today and kind of talk a little bit about metal casting and how and when and where and why to use additive manufacturing to complement that. We have had a great opportunity to work with OEMs, very large to very small, family-owned metal casting businesses, all throughout the United States, Canada, Mexico, Brazil, and now we're even expanding and doing some work over in Europe. So, really take this opportunity to thank everybody for joining. I was just at a foundry actually earlier this morning, and to be able to sit at a table and talk to foundry men and designers, they design their own product, and to explain to them the benefits of additive manufacturing. A lot of people think it's for prototyping, which in fact it's an amazing tool. But today we're going to talk a little bit more about how this technology can be used even into production. So my background, I was trained in 3D CAD CAM, so I was a tool maker. We made patterns and molds for the metal casting industry. Then I got into some project management and sales for large OEMs. And then we started this additive manufacturing journey back in early 2013. So I have about 12 years of experience utilizing 3D sand printers. So we'll talk a little bit about that. And we are a third generation family-owned business. So my grandfather started as a pattern shop. My father, Mark Lamoncha, is still very active. He started making sand cores and molds for foundries. And then we started this venture, together about 15 years ago on looking at, using 3D printed molds and cores. So today what we're going to talk about, our relevance to the industry, who Humtown is a little bit, just so you can understand, our background. We're going to talk about the additive manufacturing, the growth of it. As I mentioned, we've been involved for 13 years, but, you can go back to Ford Motor Company and some OEMs that have brought some of the first, 3D sand printers over to the US. We're talking, over 20 years of experience, so this is not a newfound technology. It's been around quite a while and it's very mature. So we'll talk about that. Talk about some of the applications. Today, we're going to focus only on binder jetting and primarily sand cores and molds for the casting industry. And then, how can your organization thrive, by partnering with this technology, whether it's, using a solution provider like Humtown or, another way of incorporating this technology, even up to, buying and installing these pieces of equipment, which we've helped, very large OEMs do, over the past 10 years. So that's what we're going to go over today. So like I said, Humtown, how are we relevant to this industry? In 1959, my grandfather started in this little garage with a partner that you see at the bottom of your screen. It grew into the building to the left of that. That was our pattern shop where we made hardwood patterns, and core boxes that we would, supply the local foundry industry. Ohio is one of the largest metal casting central areas, in the Midwest. Wisconsin and Michigan. So it's a very robust manufacturing area. And then what you see in the top of the screen, that's the Sandcore facility. And then you see about 40 trailers. We had as many as 200 people that worked at this plant making sand cores and molds, before the downturn in 2009. But we still operate that plant today. The pattern shop is used primarily. We don't do any more CNC machining there. We do maintenance and basically take care of the core boxes, minor repairs, revisions, to keep that plant operational. We've had a few legs along the journey, but in 2024, we actually procured what was a former Gorant chocolate factory, about 80,000 square feet of manufacturing space. But for additive manufacturing, the big draw to this location was actually that it was completely air conditioned. So binder jetting really likes to have, a controlled environment, mitigate the process variability, really try to drive out any process variables so that we can get good product for our customers. So we've moved all 12 large format sand printers into this building at the end of by the end of 2024, and we've been in the facility and it's been working out really, really well for us. And this is located in Boardman, Ohio. Like I said earlier, we've worked from small mom and pop foundries where the owner is the guy that melts the metal and maintains the equipment, all the way up to, some of the largest OEMs in the world. I've been in some of the largest, foundries. The foundry I was at this morning, there was 1,200 people that make, the product, that goes for municipalities, for waterworks, you name it. Caterpillar, I'm going to show you a mold here that we did for Caterpillar. Mapleton, they pour, up to 10,000 pound engine blocks, cylinder heads. Aerospace and defense is really tackling this technology, using it for consolidation of cores. And we get to work with a lot of OEMs and had a lot of really good experience, working with a lot of the universities and other organizations that bring together additive manufacturing. As I mentioned, today we're only going to talk about the binder jetting. Basically, we're going to be talking about we use sand or ceramic media. So that powder or sand is deposited. It's laid out on the job box. The print head and that sand has one part of the activator on it, and then the print head comes along, just like your inkjet printer at home, and it deposits the binder. And then when those two chemicals react, it's furan binder system that we primarily use. Then what you're left with, these green parts, that's actually the parts that are harvested. So the powder is then recoated layer by layer. The job box drops down about 0.28 millimeters, so about a quarter millimeter every layer. And then we harvest the parts. So we depowder, we remove any of the unbound sand, and you're left with the core and mold. So this was our first facility that we moved into. We had partnered with Youngstown State University. Actually, Dr. Brett Connor, who just joined SME, was kind of the catalyst for all this. He helped write a grant, with America Makes and Youngstown Business Incubator. We got the first machine with Youngstown State. They didn't have anywhere to place it, so we housed it and we maintained it and we operated it for them. And we got to work on some really, really amazing programs for the Air Force. We got to work with the Youngstown Air Reserve Station. They had a cast. It was actually a series of castings that they bought. They had to modify, weld for an aerial spray unit for the Youngstown Air Reserve Station for the C-130s. And what we were able to do is we were able to basically find the need of the casting. We designed it, we reverse engineered, designed it, cast it, and we were able to get them apart in a significantly reduced timeline, as well as they no longer had to make multiple pieces and weld them together. They were able to procure one casting, and that be the solution. So really great opportunity working with Youngstown State. That facility, we outgrew it relatively quickly. I think we moved in 2016, and by the end of 2017, we had already outgrown it with the advancement of this technology. So we're going to talk a little bit about the growth of additive manufacturing in the casting industry. As I mentioned, Ford Motor Company, brought this technology in 25 years ago, and they helped develop, product like the Eco the EcoBoost engine, and a lot of other Ford racing programs, and got to work with Harold Sears at Ford. And, he's just really innovative pioneer, and he had a great team, many people that, helped make that program very successful. But it's grown quite a bit from those days. So back in 2014, when we entered the marketplace, Ford, had two or three of the original S15 Vox or X1 type machine that came from Germany. At that time, they had a different name. I think it was RCT Pro Metal. But then at that time, X1 had bought them out, and they were making their machines in Germany, and they had a few print service centers. I think one of those was in Michigan, and then one of them was in Houston at the time. So they were selling machines and services to introduce this technology. Ford was pretty much captive. Hoosier Pattern was a pattern shop. They had just got their first machine in 2014. I actually stopped by and met with them on my way out to the University of Northern Iowa. That was who we first partnered with, was the University of Northern Iowa, and they had just received their machine, and they were looking for basically an industrial partner that had a need, or had a sales pipeline, so that we could utilize that machine. As they were a self-sustaining entity, they had to, they weren't for profit, but they had to maintain. So it was a great educational experience, because, like I said, Magellan, NAVC, Ford, they were all captive. So they were University of Northern Iowa. Dr. Jared Thiel was very welcoming to us, and this whole America Makes movement to bring additive manufacturing forward. Fast forward in about 2025, and now, instead of there being only about 5 machines or 6 machines in North America, now if you count Canada and Mexico, I think the current count for large format, meaning over a meter square, these large format machines, basically there's well over 150 of them located in North America. Humtown, we have and operate over 16 machines, whether they're our machines or we manage them as a service for OEMs. We have major, automotive, major aerospace manufacturers that have the need for this technology, and they also utilize foundries all over the United States, Mexico, Canada. So we'll actually 3D print molds to their specifications, and then we'll ship them to whatever foundry they need at that time to pour whatever alloy or whatever the lead time is. So we're actually 3D printing molds cores for new product, introduction, or NPI or revisions, if they have alterations they want to try to make, and we're actually shipping them all over. So, but as you can see, there's some major players here. Caterpillar has a micro foundry, and Mapleton, they have their own printer. John Deere has, I believe, 2 printers. So, but just like I said, alone in North America now, in basically 10 years, we've went from 5 machines to probably over 150. So we've seen an explosion of this technology, and what we're going to talk about is it's not just it's not just prototyping anymore. And I think that's what's probably one of the biggest drivers of the number of machines that we're seeing. It's the design of the casting and the ability to eliminate constraints. So, when I was making tooling, my biggest thing was, we always have to have draft. We can't have undercuts. If it's a green sand molding operation, it has to draw. All of these constraints that then go back to the engineers, and that make their job difficult, especially when you're trying to hit certain metrics, whether that's swirl or performance, horsepower. So now pumps, is a huge market, where you're able to, now the vane of the impellers, you don't have to worry about, will this core pull? Do we have to make it in segments? Now we can print, these impeller cores, totally in one piece, and, really achieve, really good balancing. So that's what I attribute a lot of this growth to. And the other growth was, because of organizations, like SME and, American Foundry Society and America Makes, and, all of these organizations coming together and actually putting these seminars and webinars, and, getting this knowledge, out to the people that need to know how to access it and to benefit from the design of utilizing additive manufactured molds and cores to get castings. As I mentioned, we're fully commercialized for manufacturing now. I still talk to some of the direct metal printing guys, which is a fascinating technology, and I love it. And we're actually partnered with the Youngstown Business Incubator. We just put in an XJet, part, but we're going to be printing very, very small particles for pieces that weigh ounces, not pounds. So I always put this slide in to let people know that we are fully commercialized for manufacturing. We buy our sand, essentially in rail cars. So when we're talking to our suppliers, we're going through over 4 rail cars of sand per month, which is over 500 tons of sand every single month that we're printing. So, when people want to set up one of these machines and they consult with us, I'm always asking the question, where are the docks? Where are the cranes? These machines were developed for the laboratory, but now have moved into a full scale, fully commercialized production environment where everything is being done in large amounts. So if a facility doesn't have a dock, I highly advise it and strongly urge people to do that, because when you're bringing in this much sand, you need a lot of space and a lot of room. These printers can turn around a lot of material. All right.
Brandon, before
Yeah,
you continue, we do have a couple
absolutely.
questions in the chat. The
Great.
first one is, does your company have a security clearance?
No, I mean, we do ITAR. We do not have security clearance up to this point. A lot of times, the cores and molds that we are sent to print, they're not the complete component. A lot of times it's a casting drawing, but we don't actually have a security clearance. But we can work in ITAR and other environments, but we've not had the need to actually have a security clearance at this time. Great question.
Gotcha. Another question, what happens to the sand after the molding?
Yeah, great question. So we, just like, in the past where we made cores and molds for foundries, we send the mold and core to the foundry. Some foundries, if they're doing a prototype, they may just take that mold sand and, they may just, put it in their waste hopper, and, it can be used as landfill or top coat. But a lot of foundries, which is really nice to have, sand reclamation. So they'll take, that sand, those cores and molds, put it in, mix it right in with their other sand, whether it's, we've seen this at green sand foundries or no bake foundries, and they literally just take that sand, put it right through their reclamation process. Usually it's thermal, burns off, any of the resin, and they're able to use that sand again in their molding line. But great questions. Thank you.
That was it for now. Thank you for answering those. Again, to our audience, if you have any additional questions, please put them in the chat.
Yes, thank you. So, kind of where are we at, in the curve, the investment cast, I mean, if you're familiar with investment castings, which I'm sure a lot of you are, they've been doing this for a while. Voxeljet has some technology with PMMA, where they're printing, lost wax, essentially, patterns, they're putting them in the slurry, they're coating them, they're firing them, burning out the pattern and, using that for investment. They've also been using additive manufacturing just to use, just to print, now with like stereolithography and, multiple other disciplines. So this isn't really new for the investment cast community. They've been using additive manufacturing for a long time. There's some really great foundries out there that have a lot of disciplines of, different ways to achieve cast, quick turn, investment castings, but, the cost is still there. It's still very significant. As the slides that previously shown, you can see, the adoption of this has really taken off, in the sand casting world. So we are now, becoming, into that late majority. We're no longer, early adopters or innovators in this space. That was Ford, and NavC, and some of in the Hoosier Patterns of the world that, we're getting, on us, that we're getting into that, back in the early 2010s, 2010s. So we've definitely started to see more and more, wide scale adoption of this technology. And as I'm going to discuss, it's not just for prototyping and MPI. We're starting to really see, the advancement of this into production. So that's pushing that along. And some other things that we're seeing, a lot of you that are, out there designing and, working with foundries. There's still a few foundries, even this year that unfortunately have gone out of business. But we worked with someone to kind of do a study of, where we think that is. And we are actually starting to see that level off. I remember, 10, 15 years ago, I mean, it seemed like every month, we were losing foundries. But that started to really level off. And what we're starting to see, especially as I'm going out, more and more foundries are really getting into their niche product, what they're really good at. And some of that, involves using additively manufactured cores. Grady is a great example of that. They're an iron foundry up in, they have multiple locations, but they've really adopted this at their Iron Mountain facility. And Kyle Peterson does a great explanation, and they basically reduced, their 3D or their conventional core room by, like, let's say a factor of 10, machines were replaced with essentially 2 or 3 3D printers, and they make highly complex multiple core assemblies, like I'll show you here in a moment. But what it does is it allows these foundries to really specialize in certain castings. And what they're starting to see is that the value of the foundry shipments is actually starting to climb. So what we're hoping is less foundries closing, so we have more of a robust supply chain here in the U.S. And as they utilize different tools, which additive manufacturing is just one tool, in their toolbox, that their value of their shipment of their product will go up, and they'll become more profitable and more stable in the market. So as I mentioned earlier on, 2015, we got our first machine. 2016. So in less than 3 years, we had gotten our second machine, and we moved into a leased space. It was a former Mitsubishi plant just down the road, and it was very large format plant. Unfortunately, it wasn't climate controlled, so we had a lot of headaches with operating the machines. But in 2019, we moved into that space, and once again, we quickly quickly evolved as a company. I thought we had too much space. I thought we were crazy, and my father was crazy for leasing such a large space. But as you can see, in 3 short years, we had completely. We had about, I think at that time we had about 10 large format sand printers in the building, and as you can see, we had filled that space up pretty nicely. So like I said, we ended up finding a space in 2024 that was actually air conditioned, and we were able to purchase that. So as far as Humtown has gone, you can see that we went from our first machine with Youngstown State University in 2016 to, in 2022, we already had over 10 of these machines. And now we have, 16 machines between our Youngstown facility, a facility that we're working. We have a machine in Los Angeles, so we're covering the West Coast with that machine. And then we have a joint venture with a company in Germany. So I'm able to do a lot of printing for my U.S. OEMs that do product development in these states. When they want to take that and transfer it overseas, now they can still stay with us. We can print and ship their molds and cores to different foundries throughout the EU. So it's working out really nice. So that kind of covers, who Humtown is, how we've, and then we've seen the growth of this technology in the industry. Now I want to really focus on, and hopefully we get some questions and some dialogue. But now I really want to talk about some of the applications of these cores and molds for the industry, and some of the benefits that we're seeing. So this slide, I worked very early on with GE's Center for Additive Technology Advancement down in Pittsburgh. And this was back in the early, back in 2016, 2017 timeframe, I believe. And, we were very, very fortunate, to be involved very early on. They actually allowed us to kind of help guide them and show them which machines worked well. But so this slide, and it, goes back to those days. And it still holds true today. So the speed to market, the only thing that might be off on this now is getting conventional tooling for a part like this. You probably couldn't even get it in 12 weeks now. I would say with the backlog that I've seen at pattern shops and tooling shops, across the US, I would say you're probably a much closer to like a 14 to 18 week lead time, for a complex tool and core box, to make a casting like this. So with 3D sand printing, we got the file from the customer. We ran simulation modeling on it with a partner. We don't have simulation modeling in-house because most of our foundries do it themselves and would rather do it that way. But anyways, we had the CAD model, we ran simulation modeling, we pulled, the cope, the drag, the cores, sent that to a foundry in Pennsylvania. They poured it, got the casting back, did a color map overlay scan to validate it. It was ground up and sent to the customer. And they had castings literally in 3 weeks. Now, I mean, that was pushing, that was us having our own printer. They had their own printer, us literally loading it in the back of a truck and driving it to the foundry. But, I mean, we were able to get good castings, in 3 weeks. And, in some, there's no way in tooling, to achieve that result. So, we still see that today. We get a call on a Friday. Hey, we have this design. We really need to get this casting. Can you get it printed over the weekend? It's kind of like UPS Red, right? If you don't mind what you pay to get it there the next day, you can do it. So, they paid us to work the weekend. We print it, we ship it out on Monday, and we have foundries still, getting castings in very, very short lead times. Now that we have 12 printers, it can be even a little bit shorter. Like I said, a couple of days, we're actually getting castings. But what we're really starting to see now is more of the design aspect. And this is what I was talking about earlier, like Grady and some of the foundries that are really engaging in this technology to eliminate the mess of cores that you see on the left-hand side. So that was a job that we had quoted at Humtown, the first slide, our conventional core facility. We had, I believe it was 2 or 3 different family boxes. So a family box, you have multiple cores in a box, in which we actually hate that because if you scrap one of the cores, now you got to reblow it, and now you're making essentially an extra scrap core of the other one, and they never break evenly. It's not like it's one for one. You always have one cavity that blows really good and one that doesn't. So then you end up at the end of the run having to block off that cavity, and then you're running a 2-gang box and you're only blowing it for one core. So it's extremely inefficient. It takes a ton of time, on your core blower, and, just wreaks havoc on your schedule. But anyways, I think we had 3 or 4 different family boxes. We would have to set those up, blow all those cores, take those cores then to an assembly area where we had people that, had glue, fixtures, gauges, and just basically a mess of trying to assemble all of those cores. And I love when I do these presentations in person because we actually have a set of those cores 3D printed out of plastic so people don't break them. And I say, how long, will it take you to assemble this? And it's incredible how long it takes. And I mean, of course, once you get into the rhythm of it and have some jigs and fixtures, you can do a pretty good job. But we actually quoted it head to head, our conventional tooling versus what it would be. As you see on the right, our response was, a single 3D printed monolithic core, no glue, no stacking tolerances, the accuracy. I'll show you another slide here in a little bit, the accuracy is so much more improved because you don't have human error, you don't have stacking tolerances, and the big thing in casting is glue. Glue is extremely reactive to metal. It's going to create gas pockets, and it's just going to wreak a lot of havoc on your actual casting process. So anytime you have a core that you have to glue, you have to be very certain that you don't get any glue drips or you don't have any excess glue, because if the metal hits it, you're definitely going to get a gas blow in your casting. So this is what we're seeing more and more of in production. And we're encouraging more and more designers to take advantage of this, because also this core, we don't have to worry about putting draft on it. So we made a hydraulic housing, and it was for fluid, and it was for on an airplane. And basically what we did was we took their original design, we went back to the designers and said, if you could optimize this, what would that look like? And they said, well, if we could get rid of the draft, then we could get rid of some weight and we could increase capacity of this tank. So we went ahead, they designed it, and we 3D printed that core for them, and they ran it side by side. And I forget how many ounces or pounds they shaved out of the casting, but it was significant. And we had a very happy customer, and I believe we printed for them for a while, but now I believe they have multiple 3D sand printers at their foundry making aerospace casting. So, the stories, go on and on. But I think sometimes we just have to sit down in, venues like this and really discuss, the advantages of when to where to use this technology. Like
Brandon,
I
before
said,
you
yeah,
continue, so
yeah,
sorry
of
for
course.
interrupting. We got a
No,
couple
of
more in
course.
the chat.
I
Three
love it.
questions here. What
Yeah.
is your preferred CAD format?
Preferred would be step followed by parasolid. We can take an STL. That's what a lot of the printers still use in like NetFab and some of the softwares. But I always prefer, a step, and that way we have, if not all of your parametric, all your data. So definitely step.
Great,
Great
great.
question.
My second question here, what are you simulating before printing? Are you simulating the printing process?
Great question. In metal casting, we run, like one of the brand names would be Magma or Flowcast or Flow 3D. These are simulation softwares for how the metal is going to essentially chill or and shrink. So what we're looking for, like in this casting that I had shown here, is we're looking for any areas where we may need to add a riser, or if we have, if we're going to have shrinks or porosity. A lot of times with chills, we can drive that porosity to an area that's going to get machined or where it doesn't matter. So great question, because I did kind of breeze through that. We don't really need to simulate the printing process. We have that down pretty well, so we don't do any simulation there. All simulation that our customers do or that we do with our customers is basically on the solidification modeling of the casting. But great question.
Great. Couple more coming in as we're going through this.
Yeah.
What surface RA can you get from a casting? We have a lot of O-ring grooves and surfaces. Would that need to be a secondary machining?
Yeah, because we're not actually making castings, I don't really get I always get, especially from our aluminum customers, oh, it's a little too rough, with coatings, and if we orient the part properly, anytime you have an angle, you're going to see your build lines, your stair steps. Can that be avoided? Yes, they're working on software to with dithering and grayscale to try to eliminate those steps, but it is still there. Orienting the part, we can move that. You want to try to get things that are more planar. Try to make them surfaces that you really don't want to finish, try to get those more planar so that they're flat and you don't see the build lines. We can put coatings, so we have refractory coating that we can apply, and get down closer to like probably like a 250 to 300 RA. But our iron customers, just because of the temperatures and everything, I mean, most of our iron customers say that the castings that come for 3D printed molds, are the same or better surface finish, in most cases. So but the aluminum, aerospace and automotive, we definitely do see, a lesser quality, because we're not actually blowing or hand ramming the sand under pressure. We're basically laying the sand layer by layer on the printer. So we definitely don't get as good a surface finish, but great questions.
My next one here, are you able to remove all the draft required for sand casting or just in certain areas?
So if it's a 3D printed mold, on the core print, sometimes just for close over, we will have draft. But as far as the actual casting geometry, I mean, I'm going to show you a slide here in a moment where we have complete, undercuts, backdraft, no draft situations. So yes, we can completely eliminate draft. Now, as far as mold assembly, like I said, when you're closing over, we still have to have these molds open to be able to clean them, to harvest the parts, to depowder, you will. And there's videos on our website, showing that. So we can't just print a box. We can't print the ship in the bottle and get all of that sand out 100%. So we still do a cope, a drag, and sometimes a core. We can integrate a lot of cores into the drag, and we've done that a lot. But yes, I would say we can completely eliminate draft on cast features, if that's a benefit for the application.
Awesome. Final question for now. And again, thank you to our audience for sharing these. What
Yeah,
is the max size of a part that can be cast? For example, a hydro turbine blade.
the
Is
answer
it?
is yes. So on this slide here, this was 31 different prints. This was a 6,000 pound iron casting for a D11 tractor. And it's like Legos. I mean, we can literally build this as large as we want. The DOE did have a program with VoxelJet. They are one of the large format 3D sand printing companies out there. They were making a machine, I believe, don't quote me because I'm not as close to this machine, and there's only one in development, but it is still over in Germany, and I think you can buy it. But I'm pretty sure it was going to be able to print up to 9 meters in length, and I believe it was 3 or 4 meters in width by 2 or 3 meters in height. So it was actually, I believe it was a DOE project with VoxelJet and GE for wind turbine castings. You can look that up on the internet. I can put you in touch with people at VoxelJet. My contact information, my email will be here. I'd be happy to put you in contact with them. VoxelJet also has a 4 meter machine in Canton, Michigan. That is, it is. We actually, I'm going to go see one tomorrow at a customer in Alabama. They have a large format 4 meter. I think it's 4x2 by 1 or 2 meters tall. So yes, very, very large parts. And then you can also segment them and build them with pins and bushings. And this 6,000 pound casting, when they did a color map overlay scan, laser scan of it, the part, over the length and the diameter of the casting was plus or minus 60 thousandths of an inch. So very, very accurate at very large size. So great questions. Thank you. Keep them coming because I forget a lot of what I've learned over the past 13 years that if somebody's just coming into this role or having these questions. So we love the questions. So keep them coming. All right, I think that was the last question you said. So I will keep on moving. This was one of the highly complex cylinder heads. So I had a childhood friend growing up. He had the patent for trick flow heads. He sold it to Summit Racing. He saw this technology. We used to make core boxes, the old-fashioned way on a 3-axis CNC machine with loose pieces, draw pieces. When he saw what the capabilities of this technology was, he went home and essentially designed an LS-style cylinder head, over a weekend. Did all the mold. What you see here on the left-hand side is you see all the ports were printed in place, and the water jacket was all printed to this bottom base. And essentially what the goal was, we've done studies and you get a lot of port to port variability, especially as cylinder heads get larger. I've done a Six Sigma project with an OEM, and essentially every one of those ports, when the metal, cast iron or aluminum hits it, the cores can kind of go plastic. And if there's glue, and if they're not assembled properly, you get these ports, and they tend to move. So what we saw with this, with making sure that the water jackets and the ports were all printed as one, basically we eliminated all of that port to port variability. So basically every cylinder head that was cast was roughly this exact same dimensions. So you didn't get variability in swirl or in machining. When they go to machine these castings, every bolt lug on the head is perfectly centered when they machine it, and it just really makes for extremely nice casting. So I show you that to let you know that we are able to achieve extremely high levels of complexity. He didn't have to worry about putting any draft or any any of those features on the water jacket to draw from essentially from a core box like we used to have to make it. So that's why he was able to essentially do the entire design in a weekend. Whereas if you were drafting that and had to put all the draft angles and everything to make tooling, it could be a several week process. And another great application for 3D printing, like I said, in production, this is the Mercury Verado 600. This engine has a casting. The motors are fixed on the back of this, whereas most outboard motors turn when you turn the steering wheel, the whole motor turns. On this, the motors are fixed, and just the bottom, where the propeller is, it turns. But what makes that possible is this 3D printed core here that we've used for, I think, the past 5 or 6 years. They're able to make this design. This was in one of the metal casting magazines. You can see here the casting. You can see the core inside of it. And this foundry was able to really thrive and make this part where nobody else could by using 3D printed cores. So now about every year, we're several thousand of these castings to make every engine for the Mercury Verado. So really cool project, and it really speaks. This is a very large casting too. I forget the casting weight of this, but I mean that core is basically 24 inches cubed. It's a very large part. So kind of went over some of the complexity, some of the assemblies, some of the benefits there. I know we got to wrap up here, but what I want to really end on is how can your organization thrive by partnering with additive manufacturing suppliers, and that means you could buy cores and molds with your if you have your own captive foundry, or if you're utilizing a supply chain of foundries, now you can bring this up in discussion saying, hey, you're telling me I have to have draft here, but it's critical for my component to not have draft in this area. Have you guys used 3D printing? So sometimes those conversations can pivot an entire project. Maybe they just hadn't thought about utilizing that, that in their, that in their manufacturing process. So you going to them a little more educated and asking, you might be able to, bring this up and utilize this technology to achieve your casting goal. So 3D printing, I always tell people it's a lot more than just buying a printer. We have several OEMs that bought the printer, installed it, and they didn't have the time or the energy to learn all of the nuances of 3D sand printing. Not to say that they couldn't or they aren't able to. It was just they found that their core competency was making castings, and figuring out all the 3D printing side of it was just a little bit too cumbersome. So they partnered with us, and then we have other customers that use us as a service, and then said, hey, this is working great. We need a lot of these cores. We're tired of buying them on the outside. Will you help us put a machine in? So we've done that as well, and we'll talk a little bit about that. There's a lot of options out there. Some of these are aren't even around anymore. We have a lot of the machines come from Europe, mainly Germany, and now we're starting to see more and more machines coming in from Asia. And it's really interesting to see the technology, but there's so many options. We don't have time to dive into all of them and all of the highs and lows of the stock market today of which 3D printing companies were doing good, bad, and ugly. But just make sure you really understand and go out in person and watch the machines run, time and time again. I've spent days in Germany, learning the differences between the X1 and the voxel jet, and then I've spent time in China, looking at their equipment and seeing, is it viable? Is it something that's going to be that's going to be competitive? So spent time with a lot of manufacturers, through universities, developing some of the first printers that hopefully will take off from the United States, that are actually built right here in the USA. So we're very excited for the future of that. But all I can stress is make sure you do your due diligence and really learn, because not pointing fingers, but one of the systems that's on the screen right now was a complete failure, and it's no longer even commercially viable. They won't even sell it. So like I said, I'm here with this slide just to let people know, make sure you really do your diligence and really understand, is one of these, because these are, these large format printers can range anywhere from 1 to 2 or more millions of dollars. So it's a very high cost of entry. So you want to make sure that when you enter, and hopefully you do, that you hit the ground running. So when you start the journey, like I said, sometimes buying a printer isn't always the solution. Sometimes it is, but if you do it, just really, go out and learn as much as you possibly can. The machines, they need to run, basically the more they run, the better they are. We're pumping essentially binder, which is essentially a glue, through an orifice smaller than the size of the human hair. With little piezoelectric crystals signaling for those to open and close to allow that fluid through. So you definitely want to run these print heads as much as humanly possible to get the longest lifespan out of them. Most print heads range between $20,000 and $50,000, and on average, you're going to go through one every year or year and a half. So you want to make sure that with the wear part that expensive, that you're getting your maximum ROI out of that print head. And then, added cost of inventory, if you're buying a machine that comes from Asia, are you able to get parts? How long are they going to take? Are they putting them on a boat? Are they putting them on a plane where it's going to cost, tens of thousands of dollars to air freight parts over? Same from Germany, where's your machine coming from? Where are the parts? Where's the service? And then, once, like you said, once you have the knowledge, the purchase of a machine can be so much more rewarding. You'll get to realize the benefits of a lot of those people on that screen that have put in machines and that are thriving. So, like I said, it's not to scare people away. It's just to make sure you do your due diligence. And, what do I see as, what's the foundry of the future? I don't see patterns going away. I was at a foundry today, they're going to use 3D printed cores. But, you look at the whole overall process, and like a 3D printed sand mold for their casting would be, $100,000, but they utilize the 3D printed core in one specific area where it makes sense and where it brings the most value to the casting. So, instead of buying, a $10,000 or $100,000 3D printed mold, they're buying, a several, maybe $100 3D printed core, but they're able to get and achieve a casting that they wouldn't be able to get any other way. So I see patterns, always being there, introducing a digital inventory of cores, very similar to the core that you see on the photo there, introducing that at the molding line, to year to casting. But I also see, there will be parts that will go to direct metal printing. So I always tell foundries, I say, look at direct metal printing as an opportunity, not a threat, because many foundries have, a lot of the key inspection processes, a lot of the metal knowledge, the metallurgical background. I feel a lot of foundries should actually step into direct metal printing. I think it's a really good opportunity for them. So with that, I think I've left a little bit of time for some questions, and hopefully we can get through everybody's questions before our time wraps up.
We did get a couple more in that last section. The first up here, do you run into any issues with porosity?
Yeah, I mean, are we talking about porosity of the core and mold, or are we talking about porosity in the casting? The answer to the casting is absolutely. That's why we run simulation modeling. You always have the opportunity for porosity in castings. Now, if you're talking about the 3D printed core and mold, I would say no, because if the printer performs, like it's supposed to, we're achieving uniform density. Whereas when we try to blow cores, we get spongy or cores that are porous because we get no fill situations where the sand will not blow into a cavity. So hopefully I answered that holistically. If not, right back into the chat, be more specific. But I would say yes, you still can have casting porosity, but as far as molds and cores, it's more of a uniform density.
Great. Our next one here is the binder and inkjet head UV curing application. And what is print times of mold in relation to casting size?
Great question. So no UV. This is strictly a chemical reaction, furan binder. So the sand is mixed with one part of the chemical, which is the activator, which is an acid catalyst, and then the binder is like a furfural alcohol that is coming through your ink, basically an inkjet printer. So when those two chemicals meet, then a chemical reaction takes place. So no UV is needed. As far as time, the printer that you see there is the printers that we own and operate for ourselves and our clients. Basically, it's 1,800 millimeters, so just shy of 2 meters by 1 meter by 700 millimeters deep. That entire job box can run, based on how many parts you nest and really cram in there. But the full 700 millimeter build time is usually between 18 and 20 hours. So
Okay.
that hopefully, and so if we can get 1,000 cores in there, we get 1,000 cores in 18 hours. If we get one big chunky mold for Caterpillar, like I showed you that picture of me standing by, then you get one chunk of a mold in 18 hours.
Gotcha. What is the current ballpark cost per cubic inch? I imagine the price has changed since I last got a ballpark
Great.
estimate circa around 2017.
Yeah, no, absolutely. Great question. Straight silica sand furan binder pricing, I would say, is going to be somewhere in the 10 cents cubic inch for a one-off mold or core, then you could probably see that, 10, 12% less if you're starting to talk about, thousands of repeat cores. And, hopefully with the advent of a few technological breakthroughs in the printers, and the speed increases, hopefully we can get that down a little bit more. But yeah, when I started this, the going rate for 3D printed sand was between 18 and 20 cents a cubic inch. So we've almost cut it in half in 10 years. So we've made some progress, but you consider an air set or a blown core, on average probably 1 to 2 cents cubic inch maybe. So we still have a gap that we need to close to, and that's why I don't think traditional molding and core making is ever going to go away. At Brembo up in Homer, Michigan, when they're making 1 million cores a week.
Absolutely. Um, Next question here. For manufacturers integrating 3D printed sand core/molds, how do you balance design freedom with process control, especially when implementing real-time monitoring or digital twin workflows?
So that was a great question. There's a lot to it to unpack. Basically, you know, I mean, the beautiful thing is we have a CAD model of the part. We can do color map overlay. I have a slide. I didn't show it here today. We have basically a cobot, a company, they've developed a cobot, and they can actually, so for aerospace or highly complex needs, we could basically do a color map overlay scan of the core and lay it right against the model and make sure that, that it's exactly, what the customer is requirement is. So I feel that because we have CAD, you look at, you know, we deal with this in aerospace a lot because they've been making these castings for these planes since the 70s and 80s, and they've been using this tool that a certain person has done over and over and over again. But when that person isn't there, they see quality defects or they see quality slips. So I feel that by consolidating and eliminating the human error, the stacking tolerance, the glue, and then having that all as a CAD file to do a color map overlay scan of, I feel like that's one of the best ways, to duplicate success, and have, digital twin and have, essentially, a verified manufacturing process. So I hope that answers the question. If not, I'd love to talk more offline about what your specific needs are or questions are, because there's a lot to that. And, I mean, and some of that is still honestly still being developed. I'm at the AFS tomorrow. We have a 3D committee meeting, and we're still developing standards, and we're still working to develop, more and more process control to eliminate, the variability. So great question.
Our next one here. Do any of your customers use parts where high vacuum is used, such as chambers, or would the parts be too porous?
No, absolutely. So there is a casting process called V process, and they actually draw a process. So if the cores are too porous and the vacuum does draw in, we can put a refractory coating on the core, and that solves it. So they use our cores all the time. We've also found a tooling application with a partner called Catalysis, where they actually make vacuum form tooling using our product. They infiltrate it to give it strength, and because it's porous, they can draw, essentially they can draw through the part. So it's a benefit. So yes, there is, porous, like the cores are porous, so you can get air through them, so they do vent very well to get gas out. But if it's like a V process where you're drawing a vacuum, we can certainly add a coating, and then that would seal that up so that the cores can be used in a vacuum process.
Great, great. We did get a question here. Brandon, are you and Elise in the same room looking at the images? Nope, teams' backgrounds are just great. We happen to pick the
Yeah,
same one today.
yeah. I realized that after my travels of being in a hotel room, everybody might not want to see, my Hampton Inn backdrop. So I figured when I saw yours, I was like, oh, that looks actually pretty nice. So yeah,
Teams to the
good question.
rescue.
Yep.
The next one I have here, is there a direct contact for your Los Angeles location? And more in general, what's the best way to get in contact with Humtown?
We have the best way, if you have CAD modeling and you have, files that are ready to print on our website, there's a 3D RFQ page. You can literally upload your part right there. And we use a quoting software that basically it brings it in, and I get quotes out to customers in minutes. I'm kind of heading up the operation out in LA, so feel free to reach out to me. We're right in Huntington Park, so only about 20 minutes from LAX. So we're really close. We have a lot of foundries out there. There's some aerospace and some pump foundries that we work with. So I'm out there quite often. And we're actually going to do a seminar coming up in March. So be on the lookout on our webpage. We have website, LinkedIn, all of that. But and there's my email. By all means, get in touch with me, and you can see I can meet you to show our facility in Los Angeles, in Ohio, Germany, wherever you want to go.
Awesome. And Sidra just did put the link in the chat for Humtown as well. We are very close to the end of our time. I have two more questions here in the chat, and then I'm going to see if we can get to them before we completely run out. This next one here, in what situations can metal AM be effectively used to complement traditional welding processes in the repair and optimization of metal cast components, such as to reduce weld defects, improve geometry accuracy, or enhance structural strength?
Yeah, we don't use a whole. I mean, we're generally dealing at the casting level at Humtown. Working with foundries. Um, you know, there's so many different disciplines. I've worked with so many different OEMs that actually at GE's CADA facility, they had every discipline of additive. So they had the DED where they were actually taking huge castings and bringing them in and actually being able to use different additive processes to basically build an area back up so they don't have to completely remanufacture it. So there's so many of those technologies out there. I wish I had more time to know about more of them. But primarily what we're using this technology for is the development of a new casting. There's not really, I mean, if you had a large casting and there was an area that you wanted to recast just that area, sure, we could scan it, and then you could take, if it's a steel casting, you could take this component that's new, maybe has new gear teeth on it, basically cut out the old, put this in, weld it in. But that's, as far as I know right now, that's the only thing that we would be able to help with. You'd have to find out, different, DED, different energy, cold spray, for building up, existing castings to remachine them back down.
Gotcha. Okay. Last question here. How do you see sand printing competing with giga size die casting?
I think I mean, so great question. And they are using, I know, some of the people that are doing giga casting are using large format sand printed molds to make certain components. Die casting and sand casting typically aren't the same animal. People that are buying a die casting, are spending a lot of money for tooling because they want to get a low piece price because they're buying, millions of them. They're making the die casting, they're, high volume. But I do see, and we have used 3D printed sand molds and cores, to complement, that size of casting, where they needed, the structural, or, they weren't able to do the die cast. But I still feel that, if they have the money for the dies and the tools and, to get the properties, the material properties of a die casting, unfortunately, you're still going to have to tool up and die cast. You're not able to get those same properties and qualities out of a sand casting every time. But great question, and I think it's very complimentary, but I don't think it's going to be anything that can replace, or maybe you could prototype that size of a casting using the sand cast, knowing that it's not going to have the same properties, but for fit form, partial function maybe. But that's kind of where my thought is with it.
Gotcha. Well, this has been a great Q&A session and an overall great presentation. I want to say thank you to Brandon for sharing with us Humtown's evolution and the transformative role of additive manufacturing in the casting industry specifically. We are incredibly grateful for your time and the knowledge that you shared with us today. I also want to thank our attendees for joining us today. The conversation in the chat, the questions that were asked, it created a really wonderful program. We appreciate viewers like you. SME membership looks forward to bringing you more engaging conversations and insights. Be sure sure to register for the upcoming Manufacturing Excellence webinar next Wednesday. We will have the registration link in the chat. If you're not a member of SME, now is a great time to join. Doing so, you can register for all SME membership programs and watch programs on demand for free. We are also always striving here at membership to ensure the content we're delivering is high impact and valuable. We'd love to hear your thoughts about today's session, and we will have a short post-event survey linked in the chat. We highly encourage you to fill it out to let us know how we're doing. To wrap this up, Brandon, thank you again. Thank you for joining us and presenting this
Thank you.
information. To our
Great to be
attendees, thank
here.
you. We hope you have a wonderful day.